my name is Mil Ovan, Worldwide Marketing Manager for Motorola's Altair Product Operations. The purpose of this videotape is to give you a better understanding of the Altair product, its performance characteristics, how it's implemented within a network, as well as what a customer should consider when they are evaluating the alternatives, both wire and wireless. This picture, although somewhat lighthearted, shows what the major issue facing corporations is today and will continue to be in the 1990s. That is, how do you reduce or eliminate the constraints to user mobility? How do you provide information to those users wherever they are and whenever they want that information? And how to redeploy people and their computer assets to best serve the business objectives faced by those companies in the 1990s. Looking at how wireless communications has been evolving to date, it's primarily been in the area of voice communications outside of the building. We have been evolving away from fixed telephony towards portable and now personal communications. Motorola believes that the next frontier for wireless communications is in the office domain, both for voice and data. The first envisioning of the wireless office is Motorola's Altair Ethernet product, a product we introduced in February 1991 at the NetWorld trade show in Boston. Since we've introduced this product in the United States, the product has also become recently available in both Germany and Spain. The Altair product addresses the major issue in data networking today. That is, the inflexibility and the costs associated with cabling of personal computers. I've been in many buildings, including Manhattan, where literally the ceilings are sagging from the weight of all the cables, and as this picture illustrates, those problems feed upon themselves. When you can't track the wiring, you end up running more and more wiring. So obviously, wireless can address some of the problems involved in getting connectivity out to users. Another of the problems involved with cabling is maintenance. A study was done recently that looked at LAN fault frequency and analyzed where, in the 7-layer OSI model, those faults occurred. They found that the vast majority of LAN faults occur at layer 1, or the cable layer. Cable open, cable short, and cable cut are some of the main reasons which lead to the faults located in local area networks today. So a wireless solution, if properly designed, can address some of the major issues faced in the day-to-day operation of local area networks. Yet another issue faced in the operation of local area networks is the cost element. A study done by Frost and Sullivan recently looked at all of the factors that lead to the costs of running a local area network. By far, the majority of the costs associated with running a local area network are in the areas of moves, adds, and changes. So therefore, a wireless product is not just a science fair project. It can address a real business concern and business need faced by companies. And that problem becomes worse in the 1990s if you look at the dramatic growth in personal computers and the dramatic growth in the connectivity of those personal computers. International Data Corporation, a research group, estimates that about 2/3 of the over 90 million personal computers in service in 1995 will be connected through a local area network. A wireless solution can help address that major connectivity problem in linking those personal computers together. And obviously, with the growth in personal computers, you can't have this person following you around everywhere trying to reconnect you back up to the network. I don't know who this person is, but I think he works at every company I've been at. You never see his face. Let's now turn to the Altair system itself and look at how it's implemented within a local area network and its performance characteristics. There are two basic components within an Altair Plus network. One or more user modules, which are connected to personal computers, printers, and other devices, and one centrally located control module, which provides communications between the user modules and the wired network. The control module is the traffic cop. It's placed centrally in the work environment and typically provides a coverage area anywhere between 5,000 square feet and 50,000 square feet, depending on the kind of building construction you have, the types of wall materials you have, and so on. Each Altair Plus control module will support up to 50 Ethernet devices in that coverage area. The Altair Plus user module is rather distinctive from the other wireless LAN alternatives since we've designed in the flexibility to support up to 8 connected devices per module. Both the control and the user modules also have a range of connectivity options in that we support thin net, thick net, or twisted pair wiring. As seen in this office depiction, the user modules can either be placed on desktops or on top of cubicle partitions. And the control module can be placed on such things as a wall, on a file cabinet, or appended to the ceiling. This product is designed to be very easily installed by a user. To install, plug the supplied thin net cable into the back of the personal computer's BNC port. Plug the other end into the Altair user module. Plug in the power and wait a few seconds. After confirming that it has reliable communications with the control module, the user module's green light indicates that Altair is ready for full-time, high-speed Ethernet communications. The overall method of installing the Altair Plus 10BASE-T model is very similar, but rather than using T's, terminators, and thin net cable, simply take the supplied twisted pair cable and connect it to both the user module and the PC port. For connecting multiple users to a hub, simply swing the plastic door on the back of the UM to access the hub port and connect the wire to both the UM and the external hub. Now that you understand how an individual user module is connected, how do you determine where to place these within an office environment? How do I know where to install the user modules? Is it within the coverage area of the control module? And so on. Well, first, you'd have to look at the area that you'd like to serve and place the control module in the center of that work group. Where you would place the user modules depends on whether you want to use those in a single user configuration or you would like to attach multiple users to each user module. On the bottom left hand of this diagram, it illustrates that there's a group of users who don't tend to move very often and they're close together. So it makes sense in that part of the office to connect those multiple users into one user module. Hence, you would realize very significant per port savings for that cluster of users. On the right bottom part of this diagram, it illustrates that although there is a cubicle user located there, there's just a single user attached. That's because this user tends to move more often, so a single user module is devoted to that person. This picture also illustrates that on the top part of the diagram, the user modules are placed within an enclosed office. The Altair product works both in enclosed offices as well as open offices. It's not a line-of-sight technology, nor does it require the user to aim these products at each other. In those enclosed office environments, it's natural that you would most likely connect one personal computer or one user to that user module. So there is a range of ways which you can connect these products depending on how often you move the users and what degree of per-port savings you desire. Next comes the issue of, well, how do I know I have the proper coverage to connect all these users over the Altair radios? What can simply be done is a control module can be temporarily suspended in the center of the work environment without connecting to the file server. Once it's plugged into AC power, you would then go to where you would like to put those user modules, and rather than connecting them to the personal computers, you can simply plug them into AC power. If the green light stops flashing, you know that you have a reliable communications link. If you are on the fringes of the coverage area and the light blinks, you might try moving the user module over just a couple inches, which might be enough to ensure coverage and connectivity to the control module. We've designed the intelligence into each module such that a simple light will indicate to you that the product is in the coverage area and is in operation. What comes with every Altair Plus product? First, looking at the Altair Plus user module, both the 10BASE-2 and the 10BASE-T models consist of a user module, a low-voltage power supply, simple network management protocol MIB2 agent, which is used for remote monitoring of the Altair modules, and an easy-to-understand user manual. The 10BASE-2 model also includes 10 feet of thin net cable with 2 BNC T connectors and 2 50-ohm terminators. The 10BASE-T model substitutes the above cable and connectors with 10 feet of twisted pair cable. A mounting option for the user module is this $95 universal mounting bracket, which allows the user module to be mounted either on a cubicle partition or on a wall. The Altair Plus CM includes the same contents found in the 10BASE-2 or 10BASE-T UMs, but adds as standard both a service port cable, which permits access to the control module's tables, and the universal mounting bracket. Since Altair is a wireless system, there's a tendency to look at it as a wiring versus wireless decision. But in fact, we've designed the Altair network to be a complementary solution to the wiring that's already in place in many companies. We see it as a way to extend the reach of wiring that's already there, which enables greater flexibility in providing information to users. In fact, Altair can be deployed in a number of ways. If there is an already in place fixed wired local area network and there's a desire to add more users, Those users can be simply added by deploying a control module on the backbone of the wired local area network and service those new users with user modules. In fact, we have several customers who have reached the physical limits of their cable run and couldn't service new users. Well, with Altair, now they can extend their reach with radio to address and add those new users. Also, if you would like to create an entire new wireless LAN, that can be simply done by attaching the control module directly to a file server and adding users to that wireless LAN with our Altair user modules. Wireless is such a new category of product that customers wonder, well, what should I consider in evaluating Altair against some of the other products that have appeared on the market in the past year or so? There are a number of factors that should be looked at, ranging from ease of installation and use to performance. Why don't we look at each one of those in greater detail? First, turning to ease of installation and use. The wireless system should be, by design, easier to install and operate than the wired alternative. You shouldn't ask the user to be an RF engineer. You shouldn't ask the user to be a software programmer. You shouldn't ask the user to invoke special commands in order to access the wireless link. And finally, if there were a power failure, the system should come up automatically by itself without user intervention. The Altair product has a number of what we call auto-configuration capabilities to make installation and operation easy. First of all, the user module automatically learns the addresses of the device it's connected to, so it doesn't require the user to do any special programming. As a second level of Altair configuration capability, the control module automatically learns the addresses of all the user modules in its coverage area, so it doesn't require the network administrator to program those modules. And finally, when moving a user module, let's say from the first floor of the building to the second floor of the building, the user module will automatically search and lock onto that new control module, thus not requiring either user or the network administrator to program the module. Another ease of installation feature is a Motorola technology breakthrough, which we call our Intelligent 6-Sector Antenna. It's an antenna that chooses the best of 36 potential communications paths so that if one of those communications environment changes, if a door opens or closes, if somebody reconfigures an office partition, the module will automatically readjust itself to that change in the communications environment. Another purchase decision factor is flexibility. The wireless system should be flexible in how it's set up. You ought to be able to move and add and change to that network rapidly and reuse the product in other parts of the building. In fact, there was an interesting trial of our product conducted by Network Computing magazine recently. What they did was to take our product, disconnect their users from their wired local area network, and connect Altair up to that network instead. The time it took to install a 16-person network was 25 minutes with Altair, which speaks to how flexible the product is in installing and moving it. With Altair, a user can be back on the network using their personal computer even before the furniture arrives. Another factor that a customer should consider in the purchase of a wireless product such as Altair is how it compares against the wired alternatives. We asked KPMG Pete Marwick to perform a study of how Altair compares against the wired alternative, in this case 10BASE-T. One of the things to look at in that cost comparison is the percentage of nodes moved per year. It can vary anywhere from 0% a year to well over 100%. In fact, in our own cellular systems group, where this product finds its technology heritage, our move, add, and change rate is well over 100% per year. As an example, this chart illustrates that users who experience 25% or more moves annually will experience break-even with Altair in less than 1 year. The other factor that should be looked at is what the cost per node move is. And again, that will range anywhere from $150 per move to well over $2,000 per move in certain cases. This chart illustrates that at a 50% per year move rate, across all the move, add, and change cost curves depicted, Altair pays for itself in less than 1 year. Since each user module can accommodate up to 8 attached devices, there are significant per-port savings achievable with Altair. We believe that the upfront installation costs of Altair compare quite favorably with the wired alternative, notwithstanding the savings achieved with Altair over the life cycle of the network. And importantly, Altair can be reused when moving to new premises, so that if you are in leased space or rented space, you can literally pick up this infrastructure and move it to your new location and reuse it. you don't have to forsake your investment and reinvest in a new infrastructure with Altair. The Altair Plus control module, which supports up to 50 Ethernet devices, is $3,995 for either the 10-base-2 or 10-base-T models. The Altair Plus user module, which supports up to 8 Ethernet devices, is $1,195 for the 10-base-2 model or $1,095 for the 10-base-T model. The Altair Plus price will depend upon how many user modules are deployed in a given coverage area, as well as how many computers are connected to each user module. For a fully loaded 50-user Altair network, the price per port can range as low as $250. But more importantly, companies can now do things with networking that they were unable to do before because of the constraints or limitations imposed by wiring. Security is another purchase factor that naturally comes up with radio, sort of what I equate to a bear-cat Skinner mentality. That is, if it's radio, I can intercept you and listen to you. The security of a wireless network will depend on a number of things. First of all, what are the propagation characteristics of the radio signal? The wireless LAN should be designed such that the signal is well contained within the serving area, and that is a function of both the transmitted power and the frequency used of that system. For example, the higher the frequency, the better contained the signal. Also, the lower the power level, the better contained the signal of that wireless LAN. As well, does the wireless LAN have ways to scramble or encrypt the data and ways to restrict access to that network? Our concept of security was similar to the concept of home security. That is, if you could demonstrate to the burglar that you are a very secure premise, they'll go down the block to find an easier mark. Altair was designed such that if someone were intent on compromising a network, there would be easier and far less expensive ways to do that on the wired alternative rather than trying to do that over Altair. There are a number of security features inherent in the Altair product. First of all, the product operates at 18 gigahertz, which is a very high frequency. There are no scanners available that will scan at that high a frequency. Most scanners operate at 2 gigahertz and below. Secondly, these high frequencies lend themselves to being very well contained within a building. So if you were a burglar intent on compromising the security of the network, you would probably need to capture those signals with a 3-meter dish on top of a van outside of a building. You might be a little noticeable, but let's say that you weren't. You would have to try to capture those Altair signals that are coming out of each of the 6 antennas every 2 milliseconds. One frame of data might be going out one antenna. At another moment in time, the signal might be going out another antenna. So the person outside of that building would have to try and capture those 36 potential communications paths and make some reasonable sense of them. Very tough to do. Third, we have our own unique data frame structure, which makes capturing data difficult. We also scramble the data every 2 milliseconds. Well, all well and good, but let's say that the burglar desired to buy one of the user modules instead, rather than being outside of the building. Well, first of all, you'd have to get close. You'd have to get within the proximity of that microcell of Altair coverage, and you would have to plug it into AC power. If someone were to do that, we have this feature called restricted access. That is, the control module has a table of all the user modules to which it will permit communications. It's important to note that this is a digital product and that radio transmission and reception are enabled functions by the control module rather than a passive function. So if this foreign user module came into the building, was plugged into AC power, and desired to communicate, if the control module didn't recognize that foreign user module in its table of permitted modules, the control module would never synchronize and allow that foreign user module either to listen or to transmit. And finally, if the customer is very concerned about their data, they're probably encrypting it. And if they are encrypting it, they're encrypting it at the applications layer, layer 7 of the OSI model. Altair will take that already encrypted data and transmit it through our network since we're at layer 1 of the OSI model. In summary, these attributes indicate that Altair is a highly secure network. Another purchase decision factor which customers should consider is how well the wireless LAN protects from interference. And that will vary based upon how heavily utilized the spectrum is. Wireless LANs which are at the 900 megahertz frequencies operate in a spectrum that's very crowded. Motorola's Altair product operates at 18 gigahertz, which is a very pristine part of the spectrum band. One also has to look at what types of equipment cause interference. Most office and factory machinery cause interference at about 2.5 gigahertz and below. Motorola's Altair product is at 18 gigahertz and well above those kinds of interference. And finally, what spectrum interference rules exist for that wireless LAN alternative? The spread spectrum products, which are in the lower frequency bands, are unlicensed. That is, a customer really has no recourse in the following situations. If a customer experiences interference with their spread spectrum wireless LAN from another radio product, they don't really have any recourse. They have to live with the interference. But more importantly, if that spread spectrum product causes interference to a licensed user, the FCC calls for that equipment to be pulled from operation. And that is one of the additional reasons why we went to the 18 gigahertz frequencies, so that customers can use this communications product full-time without risk. To give you a perspective on where these different wireless LANs operate, this chart indicates that the spread spectrum products are in the frequency bands around 900 megahertz, along with cellular radio and so on. The Altair product exists in the 18 to 19 gigahertz frequency band, and the infrared wireless local area networks, such as the InfraLAN product, exist in the infrared portion of the spectrum. It's important to note that Altair is the only wireless local area network with frequencies solely dedicated to this class of equipment. It doesn't have to share spectrum with such things as garage door openers, burglar alarms, proximity detectors, and so on. We think that's a key advantage in providing high-speed, interference-clear communications to end users. As you saw in that spectrum diagram, Motorola's Altair product sits sort of in the middle between the lowered frequency radios and the higher frequency infrared products. So we take certain advantages of both. Like radio, Altair's signals will pass through drywall and cue walls, and we are not restricted to the line-of-sight limitations that are faced by the infrared local area networks. Like light, however, the signals of Altair refract and reflect, and the signal dissipates rapidly outside of the microcell, and it's free from interference from other types of equipment signals. Since Altair is a digital system, unlike other radios which require one frequency to transmit and one to receive, Altair transmits and receives on one frequency, so that if the customer desires to deploy another control module, that can be done on a separate frequency. Literally, two control modules could be placed on top of each other and they won't interfere with each other, simply because they operate on separate frequencies. But still more Altair microcells can be added with what we call frequency reuse, using the same frequencies over and over in a building. As an example, if one were to desire to install the first control module, that would be done on the first frequency. The second control module placed on that floor would be at a separate frequency. And if one were to desire to add a third control module, if there's enough separation between the first and the third control modules, they can use the same identical frequency. That reuse distance will depend on the type of office walls that exist on that floor. Multiple Altair microcells can be deployed throughout a building. Because the 18 gigahertz signals are stopped by the cement and metal which compose most floors and ceilings in buildings, those same identical frequencies can be used over and over again on a floor-to-floor basis. Another factor which customers should consider is how compatible the wireless LAN alternative is with their existing standard network. Altair works with any standard 802.3 Ethernet device, any network interface card, and any PC network operating system. So Altair operates in a multi-vendor local area network environment, regardless of whether it's an IBM computer or an Apple computer, regardless of whether it's a 3Com network interface card or a Western Digital interface card. Altair requires no special drivers or logon sequences or unique cards. Connecting Altair is similar to connecting a bridge. We have source-destination addressing and filtering, and there is a 2 to 8 millisecond latency per data packet. Altair guarantees data delivery from one destination to another. I'll show how this may impact performance in a little bit. Comparable performance is another issue that customers should consider. How does the wireless system work in delivering data to an end user? As an example, in the network computing review of Altair, once Altair was installed, they didn't tell their users, who were the magazine's editors. And as the reviewer noted, these persons would be the first to complain if they noticed a difference in their PC reaction times. No one raised their hand, which speaks to the performance goal of the Altair product. As I mentioned, there's a slight degree of latency in the system in that we take data from the personal computer, put our own addressing information on that data, and send this information on its way to the control module, which then determines if it's meant for the wired network or another user module within the microcell. How does this impact performance? Well, if you look solely at how Altair compares against wire, in this example using the Novell IPX protocol, the transfer times over Altair can be up to 3 times that of wire. However, when you introduce applications into the analysis, it indicates that across a broad range of applications, the transfer speeds of Altair compare favorably against the wired alternative. In the Network Computing Magazine review, they noted that under certain conditions, the wireless system will be slower than a wire connection. But in reality, the actual transmission of information seldom saturates a system. Just as LAN traffic follows a bursty, random pattern, so does the traffic across the user and control modules. In most cases, an occasional burst of performance-impairing traffic is tolerable. For 5 weeks in our labs, we had our VACs, a number of Unix boxes, our NetWare 3.11-based lab file servers, and workstations connected through the Altair. Our labs are in a number of self-enclosed lab spaces that make up the total lab. Performance there was consistently good. Since performance depends on the application, the best advice to you is to take a few Altair modules and try it in your own environment, with your computers and with your applications, and note if there's any difference. We believe that the majority of users will be highly satisfied with Altair's flexibility and performance. Looking at the future of networking, the trend is towards multi-packet protocols, which positively impacts Altair's performance against the wired alternative. As indicated in this slide, the performance times of Altair and wire are highly similar. Yet another performance characteristic which Altair brings is the ability to segment users and increase overall performance of the network. First of all, the Altair user module keeps user module to user module traffic off of the backbone LAN, so that the overall LAN throughput is increased. What you're able to do is to segment that group of 50 users from the overall wired local area network. Secondly, the Altair control module keeps unnecessary backbone LAN traffic from the ears of those user modules, such that the overall throughput of the Altair microcell is maintained. In the final level of segmentation capability, users who are communicating with each other, who are attached to the same user module, will do so without having the user module pass that data along to the control module. So there are a number of segmentation capabilities which we bring to enable high performance both within the Altair network as well as on the overall LAN. Another issue with a wireless LAN is coverage. We believe that a wireless LAN should have coverage tailored to the department. Signal containment within and between floors are key not only to frequency reuse but to security as well. In following good LAN administration practices, LAN performance throughput and fault isolation are optimized in groups of 25 to 50 employees. So that's how we've scaled the Altair product. In fact, we've done studies prior to the design of the product and asked customers how many users would they attach to a wireless LAN. The overwhelming majority of users attached to a wireless LAN fell into the range of around 30 users. We also asked those respondents the coverage area requirement of that LAN. Again, the overall majority indicated that the coverage should be around 5,000 square feet. There are 2 basic types of LAN architectures, either a bus architecture such as thick and thin net, or a star architecture such as the 10BASE-T local area networks. Altair is what we call a wireless distributed star architecture, which brings a number of benefits over the other alternatives. First of all, having wireless UMs and CMs means that no wiring home runs to the wiring closet are required, which results in a less complex and cumbersome deployment of local area network connectivity. And being a distributed architecture, it means that you could deploy microcells as you best see fit and not have to anticipate where every user would move within a building. Looking at thin net or thick net Ethernet installations, we bring fault isolation to those types of LAN environments. With a thick net or thin net cable, if the cable is cut, the entire network goes down. However, with Altair, similar to 10BASE-T, if a user module were to go down, the rest of the microcell would still continue operation. To aid in network management, Altair has announced the availability of Simple Network Management Protocol, or SNMP. SNMP is a common set of rules for exchanging network information between a central management console and devices managed by that console. Motorola's SNMP MIB2 is standard for every Altair Plus control and user module. SNMP consists of an agent which resides in the UMs and the CMs and operates with any SNMP manager. The Management Information Base, or MIB, also resides in the UMs and the CMs and consists of a database of product information. The SNMP Network Management Console is not provided by Motorola. This agent and MIB will interface with any standard SNMP Network Management Console. Altair private MIB extensions will be available at a later date. How does Altair compare against the alternatives, both wire and wireless? Across the dimensions listed on the left, ranging from the speed of connectivity to user installability to the freedom from interference and the ability to work in both open and enclosed environments, we believe that Motorola's Altair product wins against all the alternatives. How does Altair's implementation compare against the way other wireless LANs are implemented? Motorola's Altair is on the top left corner of this matrix, and NCR's WaveLAN is on the top right corner of this matrix. The WaveLAN requires that the LAN card be eliminated, it's hardware dependent, software drivers are required for each operating system, and the applications are limited by the operating system support. In contrast, Motorola's Altair uses the existing LAN card, and it's independent of the user hardware, independent of the user operating system, and no new application software is required. The industry agrees with how we compare against the wireless LAN alternatives. Indeed, a number of magazines have given us their awards, such as LAN Magazine's 1991 Technology of the Year and 1992 Product of the Year, LAN Times Recommended for Networking Award, where they assessed all the wireless LAN alternatives and rated us #1, Network Computing's Well Connected Award, Data Communication Magazine's Hot Product of the Year Award, as well as the recent PC Magazine Award for Technical Excellence in the category of connectivity, by the way, against some very major and established players in the connectivity marketplace. Also, Altair is Novell Labs tested and approved. In summary, Altair's benefits and applicability are best stated by a user who says that it will cost us less in the long term because we don't have to tear up wires every time somebody moves. We can make strategic decisions based on business rather than on who sits where. The significance of Altair is that it provides a much more flexible way to network the office of the 1990s and eliminate the barriers to user mobility. The final factor a customer should consider is the name of the company on the product. Motorola is the worldwide leader in wireless communications. In fact, of our over $11 billion in sales, over half of those sales are accounted for by different types of wireless products. Since we've been in the business for over 60 years, nobody knows wireless communications better than Motorola. Should you have any more questions, we have available easy to understand and use user manuals. Should you require more technical information than is provided in these manuals, we also have available a system manual. Either consult with your LAN administrator or you can call Motorola directly at 1-800-233-0877. Thank you very much for your attention.